Hello and welcome to Crisp Concepts, where complex ideas become clear and simple.
For decades, we've been launching all sorts of amazing things into orbit. Satellites, rockets, probes, you name it. But we've also been leaving a ton of stuff behind. Every single mission, every deployment, every satellite that eventually goes dark, it leaves this trail of metal, fragments, and just junk. And this space debris, it's quickly becoming one of the biggest threats to our modern, super connected world.
So, let's just jump right into the big question here. The scale of this problem is, well, it's kind of hard to wrap your head around. We're talking about more than 170 million pieces of debris, and these aren't just floating there. They're whipping around the Earth at unbelievable speeds. So how in the world do you even begin to clean up a mess that big?
Before we get into the really cool solutions, we first have to understand why this orbital junkyard is such a massive deal. I mean, it's not just some clutter way up there. This is a direct threat to the very infrastructure that powers so much of our daily lives. Okay, to really get the danger here, you have to think about the energy involved. Even a tiny little fleck of paint traveling at orbital velocity can hit with the force of a hand grenade. No joke. So these things are basically high-velocity projectiles that can completely shred an active satellite. And that's why it matters to you and me. Our GPS, our global communications, even our weather forecasts all depend on those satellites. But the biggest fear? It's this chain reaction, sometimes called the Kessler Syndrome. Basically, one collision creates a cloud of new debris, which then causes more collisions, creating even more debris. It's a snowball effect that could literally make entire orbits around Earth totally unusable. So, what do we do about it? Well, the first solution we're going to look at is a pretty direct, hands-on approach. The idea is to build a robotic arm that's smart enough and sticky enough to just grab this junk right out of orbit.
Now, this is not your typical sci-fi robot claw. This is a seriously sophisticated piece of tech, designed for a very, very difficult job. See, the problem is that a lot of this space junk is made of stuff that isn't magnetic, like aluminum or composites, and it's usually tumbling all over the place. A simple claw might just, boop, knock it away. So the real solution here is adhesion. And this is where the design gets absolutely brilliant. It uses two totally different ways to stick to things. On one side, you've got this electrostatic grip. It uses an electric charge to create this attractive force, kind of like when a balloon sticks to the wall after you rub it on your hair. It's super versatile and works on all sorts of materials. But on the other side, engineers are literally looking to nature for inspiration. The gripper also uses pads with these microscopic structures that copy a gecko's foot, letting it cling to surfaces using something called van der Waals forces. It's an incredibly powerful, reusable grip that doesn't need any magnets or messy glue. Of course, just sticking to the debris is only half the battle. First, this compact servo motor gives it rotational control, which lets the gripper perfectly match the spin of a tumbling object before it even makes contact. Pretty smart, right? And then, once it has a good firm grip, this retractable mechanism pulls the captured junk in, almost like landing gear, and tucks it safely away in a storage container. Grab, align, and store. Simple as that.
Grabbing debris is one thing, but what if you didn't have to touch it at all? This next solution sounds like it's straight out of science fiction, but believe me, it's a very real concept that's being developed to move huge pieces of debris without any physical contact whatsoever. So, meet the ion beam Shepherd. Think of it less like a garbage truck and more like a super high-tech leaf blower for space. The Shepherd spacecraft flies near a piece of debris and just points a focused beam of plasma at it. This isn't about destroying the junk. It's about gently nudging it out of a dangerous orbit. So here's how that nudge actually works. The Shepherd fires this highly focused beam of ions at the target. When those tiny particles hit the surface of the debris, they transfer a little bit of their momentum. Now, it's a very small push, but when you apply it constantly over time, it's enough to gradually slow the debris down. This causes its orbit to decay until it can burn up safely in the atmosphere. The real secret to the push is in this plasma plume. As it expands out from the spacecraft, all the real work is being done by the dense, concentrated core of that beam. That's where most of the ions are, and it's that core hitting the target that provides the momentum. The tricky part is keeping that core perfectly focused over a distance of several meters. Okay, so this is probably the first question that popped into your head, right? It's Newton's third law. For every action, there is an equal and opposite reaction. So if you're pushing a huge piece of debris forward, shouldn't the force from that ion beam be pushing your own spacecraft backward? And the answer is yes, it absolutely should. The solution, though, is pretty elegant. You just fight thrust with more thrust. The Shepard spacecraft has a whole secondary propulsion system. As the main ion beam is pushing on the debris, this secondary thruster fires in the opposite direction. It creates a counterforce that holds the Shepard perfectly steady. It's this delicate balancing act that lets it maintain a precise distance from its target.
So we've looked at two incredible, almost futuristic solutions, one that grabs and one that pushes. Let's put them side by side for a second and see how they fit into the bigger picture of trying to keep our orbits clean for the future. And when you really compare them, you see they solve different parts of the same problem. The high-tech grab, that's a contact method, using those amazing adhesion technologies. And it's absolutely perfect for smaller bits of debris, things under 0.5 kilogram. But the contactless push, that's for the big boys. It uses that focused ion beam to move massive objects, like old satellites that weigh over a ton, without ever having to risk a collision. So they aren't competing ideas, they're actually complementary tools for different parts of the job. And all of this brings us to our final and maybe most important question. The technology to clean up space is clearly advancing at an incredible pace, but honestly, the tech might be the easier part of the problem. As our orbital highways become more essential and way more crowded, the real challenge is a human one. Who is responsible for all this? Is it the countries that launched the objects in the first place? Some kind of global group? Private companies? Figuring that out is the next giant leap we have to take to make sure we have a sustainable future in space.